Number 7. What is the common consecutive difference for the quadratic function u of s equals negative 6s squared plus 3s plus 4? And just because I want us to practice this, I'm going to draw that variable box and identify my values. So a is negative 6, b is 3, and the constant is 4. So this is the y-intercept, and this tells me that my parabola is frowning. That's a negative number. But that's not the question. They want us to calculate the consecutive difference at its common level, so that's going to be 2. It's a second degree equation. So let me go ahead and put in some lines here to build my table. I miss my dots on this page. They're a lot easier to draw on. These don't want to line up, but it's okay. I'm going to need at least 4. Since this is quadratic, I want to look at 4 values. So let me get one more on there and make an X a place to evaluate, and then first and second consecutives. So something along these lines. Here is my input. My function is called u of s this time, and it's negative 6s squared plus 3s plus 4. And I'm going to pick 0, 1, 2, and 3. And I'll have that extra row because I'm starting in the wrong place when I... Alright, and again, if you find that you need more values, that's fine. You can just add a row. But this is the first consecutive difference. This is the second. And I know that this will be the common one because that's a quadratic function. Okay, the first one is the 0. And I can tell you, if you want to shortcut this one, that the 0 will go with this output because that's what happens at the y-intercept. But here's why. Negative 6 times 0 squared plus 3 times 0 plus 4. Again, those first two terms disappear. They're multiplied by 0, so that is 4. Then negative 6 times 1 times 1, 1, plus 3 times 1 plus 4. So this would be a negative 6 plus 3 plus 4. If you want to break it out that far, that is going to give you a positive 1 as your output. Negative 6, 2 times 2 is 4. You have to square that term. 3 times 2 and then 4. So this one comes out to be a negative 24 plus a 6 plus a 4. So this is a negative 14. Yes. I don't have my calculator. So, okay, this one I have the negative 6 from the function, and then 3 3s are 9, plus 3 times 3 plus 4. So this is negative 54 plus 9 plus 4. And I'm thinking that that one is negative 41. I hope that's right. Okay, if it's not, I'm going to know here. So, all right, so here comes, remember, if you want to highlight your outputs, that helps a little. That helps you know which numbers you're bringing up for the differences. So here is 1 minus 4, negative 3. Negative 14 minus 1, negative 15. But remember, we don't expect it to be common at first level because it's not linear. This is not too alarming. And then minus a negative 14. Be careful with those negative signs right there. That's negative 27. So then I'll take this set of outputs and bring them up here to do the next column. So negative 15 difference negative 3 is 12 negative. And then negative 27 difference negative 15 is also negative 12. And now it's common. That's a good thing. And that's the answer that we're looking for. This problem is pretty straightforward, but it is hard. It's got all those negatives and you have to really be careful with those. So this table actually does not need that row or cell or that cell. So as these go further out the line, those columns get shorter. That's a good thing. That's a good sign.